Heyo! Welcome back. This is going to be part 2 of this lesson. Last time we did some intro to some vocab related to experiments and stuff like that. So this is day 2. Today we're going to focus more on how we're going to actually do, or the method behind experimental design. So I can describe a completely randomized experiment. That's what we're going to focus on today. Quick recap though. When we're talking about experiments, it is different than this thing called an observational study. Observational study just observes individuals and measures variables of interest, but does not attempt to actually influence responses, and we're not changing anything to try to see if we can compare, whereas an experiment deliberately imposes some treatment on individuals to measure their responses and compare between that and maybe a different treatment or no treatment at all. So, we left off with this last time, and I want to keep this in the forefront. We're gonna be using these 4 things when we're dealing with experiments. So the basic principles for designing experiments are as follows. You need to have comparison. So use a design that compares 2 or more treatments or lack of treatments. Okay? Observational studies do not do that. There needs to be random assignment. This is important. That word random keeps coming up. And we'll talk more about that in a second, but use some sort of chance to assign experimental units to the different treatments. Doing so helps create roughly equivalent groups, potentially, by balancing the effects of other variables among the treatment groups. So even if there's other things that might influence it, we have a good spread in each group. Control. So we want to try to keep other variables that might affect the response the same for all groups, and random assignment also helps that. And then replication. We want to use enough. This is not like cloning something. This is using enough of it, enough experimental units in each group so that any differences in the effects of the treatments can be distinguished from chance differences between the groups. All right? So in order to create roughly equivalent groups at the beginning of an experiment, we use random assignment. It's going to be abbreviated as RA, oftentimes, random assignment, to determine which experimental units get which treatment. Okay? If we actually use random assignment, we'll be able to actually establish cause and effect. So in an experiment, random assignment means that the experimental units are assigned to treatments using a chance process, which we've talked about different chance processes like random number generators or random names in a hat. So why always random? Why do we say this is so important? So we've done random samples. So if we're going to take our experimental units and we want to get a random sample of people to do this experiment, that helps us so that we can actually generalize to a greater population. Random samples should be a representative of the population from which they're taken. So a random sample allows us to generalize. Random samples allow us to generalize to the population. That's important. Whereas random assignment, so now once we have our sample that we're going to use for our experimental units, and we want to assign them to different treatments, that helps us with cause and effect. So random assignment hopefully will equally distribute the various levels of confounding variables into the different treatment groups, so that the only difference between the groups really is the treatments that's being given. If there's a significant difference between the groups, the random assignment allows us to conclude that the treatment caused the difference. So random assignment gives us cause and effect. Okay, we can actually say this caused this. This treatment caused an increase in this. So in a completely randomized design, you'll see this term completely randomized design, the experimental units are assigned to treatments completely by chance. It is random assignment. You can describe experiments with a diagram. You can describe experiments with an outline. You can describe them with a paragraph, but we're going to talk about those key parts that you need now. Okay? I'm going to start with a diagram just because I will tend to use a diagram, and it's going to generally look like something like this. It's a little funky for right now, but these are the things that are going to be essential to making your diagram of an experiment. you need to state the EUs. That is not European Union, for those of you who are social studies minded. This is the experimental units. Experimental units. So just a reminder, this is experimental units. So what is our group of experimental units, and what is the number? Okay, so there's 30, whatever it is. Next comes with that, we're going to do random assignment. You can literally just state random assignment here, and then down below everything, we want to actually describe how they will be doing this. So note, this is going to be usually a simple random sample. How we're going to do that. Now then we're going to divide them into groups, depending on how many treatments we have. So group 1 might have 10, group 2 might have 10. We want them to do the same. And then maybe that we have more groups, maybe we have 3. And then we want to also state what the treatment is. So this group gets this medicine, this group gets this medicine, whatever it is. And when we're done with all that, we want to finally compare. We want to say, with context, what was the difference? All right? So let's look at an example. I'm going to actually do this example with a diagram, and then I'll show you another example, and we'll use a different route. So an educator wants to compare the effectiveness of a computer software program that teaches reading with that of a standard reading curriculum. So we're going to compare a computer software program to a standard reading curriculum. And if we want to compare 2 different treatments, we want to use an experiment. She tests the reading ability of each student in a class of 4th graders, then divides them into 2 groups. One group uses the computer regularly, while the other studies a standard curriculum. At the end of the year, she retests the students and compares the increase in reading ability into the 2 groups. So use a diagram to outline a completely randomized design for this study. So let's start with the far left. What is our experimental units? All right, that is this 4th grade class. And when we're saying our experimental units, again, that's what's going to be here. You don't have to write these, what I'm putting in black, but this is just a reminder for what we talked about on that last slide. We want to also say the N. So how many are there? It does not say. So we'll just come up with a number. I don't think it says in here. Yeah, we'll just come up with a number. We'll say N equals 24. There's our number. But we should state how many are there. So now, our next step is to use a random process. This is random assignment. And so that's our second part, our random assignment here is going to be listed below, so I can keep going with my diagram, but I am going to make sure I do that. So my random assignment, we'll keep with blue here. How am I going to take those numbers? So I'm going to, those students, I'm going to give each student a number 1 through 24. Because I'm going to use the random number generator. You could use names in a hat if you want to explain that part too. A number 1 through 24 alphabetically. Where 1 is first and 24 is last alphabetically. And you can change the wording slightly if you like. I'm going to then use a random number generator to select We'll say 12 unique numbers. Assign the corresponding students to the computer group, we'll say. Assign the rest to the standard curriculum. So that is how I can explain my random process. You could use names in a hat, but you still need to go with the same things of assigning the students to something, using the random process to select. In this case, we have two groups, so they're going to each be 12. So we're going to select 12. All you have to do is select the first 12, and then you can just state assign the rest to the other one. All right? If you're picking out a hat, you could say pick 12 numbers, unique numbers, or without replacement, and then the rest will go to the other part. So that's my random assignment. I don't have to write it in my diagram. I'm just going to write it below. So what happens next is I'm going to actually make this 2. This will take me to 2 groups. Group 1 has 12. Group 2 has 12 as well. And then those 2 groups are going to be assigned treatments. That first group that we said gets the computer software. And the second one gets the standard curriculum. Once we're done, what are we going to do with those things? We want to compare what happened. So what we're looking for is going to probably be in the situation. We want, at the end of the year, she retests the students and compares the increase in reading ability. So we're going to compare increase in reading ability. And then we're done. That is our random process. So again, if I go back, this is the groups. This is the treatments. This is where we compare. So all 5 of those parts is kind of what we said in this general diagram before. And you have to state all of those things in your situation if you're describing a completely randomized design for an experiment. Now, like I said before, you can outline them or make a paragraph for all of this stuff as long as you address the experimental units, any preliminary measurements probably could be in there as well, a random assignment, the treatments/groups, and then measuring and comparing. So if I take a look at this one, I'm going to actually do it that way. So it says, can aspirin help prevent heart attacks? The Physicians' Health Study, a large medical experiment involving 22,000 male physicians, attempted to answer this question. One group, about 11,000 physicians, took an aspirin every day, or every second day, while the rest took a dummy pill. After several years, the study found that the subjects in the aspirin group had significantly fewer heart attacks than the subjects in the placebo group. We want to be able to say, with a good design, that the aspirin actually caused that. So what we're going to do here is we're going to use an outline, and you could also make a paragraph to do that. And this is what I would kind of make it look like. I've got 22,000 male physicians, and I randomly assign subjects to 2 groups. And I'm going to explain that. So I assign each physician a number 1 through 22,000, randomly generate 11,000 unique numbers. Those go into group 1, and the rest go into group 2. So I kind of divvy them up. Then I'm going to state my treatments. So group 1 gets the aspirin, group 2 gets the placebo. And then I'm going to say after several years, measure and compare the number of heart attacks between the groups. So I have all the pieces. I could put those into a sentence or into a paragraph too. We have 22,000 male physicians, and we're going to randomly assign them yada, yada, yada. We're going to do all this in a paragraph. There's more than one way you can do it. Personally, I like this route, and this route is totally allowed, just because it breaks it down. It's visually for me, and I have the random assignment below. But you can simply do an outline or a paragraph if you'd like. The idea is we need to have those pieces in there when we're doing it. So, to wrap it up, a couple things here. We're not going to do a lot of inferencing right now, but looking ahead, we will be using experiments to decide if something is like actually causing something else, like if there's actually a cause and effect. And we're going to come back to this term statistically significant. An observed effect that's so large that it would rarely occur by chance is called statistically significant. Generally, we'll use that 5% rule that we've used in the past, but there are other ways to do it as well. If we observe statistically significant differences among groups in a randomized comparative experiment, we have good evidence of that cause and effect. Okay? And the great advantage of doing these randomized experiments is that we have the evidence. We can actually say causation. There's like association and causation. It's not just like back to our correlation stuff where correlation isn't always causation. This time we could actually say that it does imply causation. So that's one of the things we're going to look ahead at in a little bit, but not today. So just to wrap up, observational studies are where there's no treatments imposed, we can only observe. There's no way to assign cause and effect to that. Experiments where treatments are imposed, and it does allow for causation. Okay? But it has to have a random assignment. The random sample part, we could generalize to a whole group if we truly are taking this from a random sample. But if we're just taking it from a group that we already have, then we can't necessarily do that. Treatment. Treatments are what is done to the participants. And then the participants are the experimental units. So it's what or who the treatment is imposed on. Oftentimes we call them subjects if it's actual people. But there's our wrap up to section 4.2a, which is all about experiments, experimental units, and the things that go along with them. So that's section 4.2a. We'll see you next time.